In this section of the course, we will look into the security aspects of Istio. We will first get a brief introduction to security in Istio, followed by the Istio security architecture. We will then look at authentication, authorization, mutual TLS, and certificate management. So, let's get started. Let us start with a brief introduction of security in Istio. Microservices have certain security requirements. When a service communicates to another service, it's possible for an attacker to intercept the traffic and modify it before the request reaches the destination. This is known as man-in-the-middle attack. To prevent this from happening, the traffic between services needs to be encrypted. Secondly, certain services may need to implement access control restrictions. For example, only the product page service is allowed to access the review service and not the details service, or any other services in the cluster. For this, we need access control. Istio allows this using mutual TLS and fine-grained access policies. And finally, we'd like to know who did what at what time. And for this, Istio provides support for audit logs. In the upcoming lectures, we will dive deeper into each of these. Let's now look at the Istio architecture and see how Istio implements security to achieve the requirements of microservices applications. So, this is the Istio architecture diagram from Istio documentation pages. Let's discover its details. Within Istio-D, there is a certification authority that manages keys and certificates in Istio. This is where the certificates are validated, and certificate signing requests are approved. Every time a workload is started, the Envoy proxies requests the certificate and key from the Istio agent, and that helps secure communication between services. The Configuration API server component distributes all the authentication, authorization, and secure naming policies to the proxies. Sidecar and ingress-egress proxies work as policy enforcement points. The certificate, keys, authentication, authorization, and secure naming policies are sent to these proxies at all times. So, this means every point has security checks, not just the entry points to the network. And this is called security at depth. In the upcoming lectures, we will look into these in more detail. Let's start with authentication in Istio. In service-oriented architecture, we need to make sure that communication between two services are authenticated, meaning when a service tries to communicate with another service, there should be a way to confirm they are really who they say they are. This is done by hardening traffic using verification options like mutual TLS and JSON Web Token validation. For example, when the product service tries to reach the review service, the review service needs to know that the request is actually coming from the product service and not from an external source who pretends to be the product service. So the traffic between one service to the other needs to be verified. With MTLS, each service gets its own identity, which is enforced using certificate key pairs. The certificate generation and distribution are all managed automatically by Istio-D. So there's nothing extra that you have to do on the services. Another area to to be authenticated is the end user's access to services. For this, Istio supports request authentication using JSON Web Token Validation or OpenID Connect providers, some of which are Ori Hydra, Keycloak, Firebase, or Google. Here is an example of peer authentication config. Authentication policies are defined by peer authentication and request authentication kind. It will be applied in the bookinfo namespace. This policy will only be effective on workloads labeled with the key app and value set to reviews. And it says that these workloads must strictly use mutual TLS. In this case, we have enabled authentication only for the reviews app. And so we have only enabled it for a single workload. This is a workload-specific policy. If we remove the selector specification, the policy would be enabled for the entire namespace. So then, this would be a namespace-wide policy that is applied to all workloads within the bookinfo namespace in this example. And if we set the namespace to the root namespace, which happens to be Istio system, then this becomes a mesh-wide policy that is applicable to the entire mesh. Let's head over to the lab and see this in action. In this demo, we will see the difference between no peer authentication policy and mutual TLS enabled. We will create a new namespace for this example, and when we enable mutual TLS namespace-wide in default namespace, non-mutual TLS traffic coming from this new namespace will be prevented. We'll start by cleaning up the default namespace. Then, we'll get the bookinfo app back from the samples folder. Now let's create a new namespace for this example. I'll name it bar. Then let's create a sample application called HTTP bin. HTTP bin will help us curl the other services. Here, you can see an interesting command, istio5 kube-inject. So, if your namespace is not Istio injection enabled, you still can manually inject Istio proxy sidecars with this command. But manual injection will change the deployment configuration by adding proxy configuration into it, so it works a little differently. Now the HTTP bin is created, let's curl from HTTP bin to a product page. We have an error, saying the Istio proxy container is not there. It seems like our container is not up yet. Let's check it. Okay, the default namespace has everything up and running. Let's check the bar namespace. Okay, here it is. We still have not the pod initialized. Let's wait for it to be ready. So yeah, here it is. Let's try this curl command again. Yep, here is HTTP success 200. So, this means from the bar namespace, we could curl our way into the default namespace to product page. Now, we'll configure a peer authentication policy for default namespace with mutual TLS mode strict. Let's try the same curl command again. And it's failing, as expected. Because we just added a peer authentication policy with mutual TLS mode strict, Workloads that do not apply the same mode cannot reach our application. Authorization in Istio provides a flexible approach to access control for inbound traffic. We can control which service can reach which service, which is referred to as east-west traffic, using authorization configuration. So, let's see how it works. With authentication policies, we now have the end-user traffic as well as service-to-service traffic secured. But what about access control? For example, we would like to only allow the product page service to access the review service and not the details or any other services. Also, the product page service is only supposed to run GET calls to the review service and not POST or update calls. We do not want anyone gaining access to the product page service to make POST calls to the review service in an attempt to update or change reviews. And for this purpose, Istio provides authorization mechanisms that allow us to define policies to allow or deny requests based on certain criteria. As discussed before, the services don't require any changes to implement authorization. This is implemented by Envoy Proxy's authorization engine in runtime. When a request comes to the proxy, the authorization engine evaluates the request context against the current authorization policies and returns the authorization result, either allow or deny. There are three actions that authorization policies support: custom, deny, and allow. The allow action allows a request to go through. The deny action denies a request from going through. And the custom action allows an extension to handle the request. Authorization policies can also be configured to audit requests. With this option, when a request hits the matching rule, it gets audited. Let's look at an example of an authorization policy. Here, the kind is set to authorization policy. Authorization policies support custom, deny, and allow actions. This policy sets the action to deny. This policy denies all POST requests from the bar namespace to the bookinfo namespace. Let's head over to the demo and look at a better example. In this demo, we're going to try authorization policies, namespace, and workload-wide. Let's check the state of our application now. Yes, it's up and reachable. So first, let's add this authorization policy for default namespace. Since this has no selectors, it will affect the whole default namespace. And the spec section has empty value, so it will not permit any traffic and all requests will be denied. Remember, it might take some time because of caching or other propagation overhead for these policies to take effect. Yes, here in the browser, if you can see the RBAC access denied message, it is working as intended, and Istio doesn't have any rules that allow any access to workloads in the mesh. We can also create some traffic into the mesh to check it on Kiali. But first, let's check our product page application now. Let's check Kiali dashboard. As you can see, from product page, we are having issues with the whole traffic coming into the mesh. It's not passing through. And here in the logs, our product page pod containers are throwing errors as RBAC access denied meshed policy. Let's check the traces. Here, we have a very dark red group of trace that is showing us the problem. Let's stop the traffic and now try creating a viewer policy for product page. For this, we'll add another authorization policy for default namespace with a selector app product page. This is an allow action, and in the rules section, it is configured for traffic coming to the service, allowing only get method. Let's apply it and try it on our browser. You can see that the policy now is allowing only the product page get method. The page is back, but the rest of the services are still not available. Remember, the top description part is coming from product page itself. When we refresh the Kiali dashboard, the graph from ingress to product page now turns to green, showing that we have some traffic passing through. When we check the service details, the rest of the traffic is still denied. Now let's step by step create our authorization policies to get the whole app working. We'll create a details viewer policy for this in the default namespace with app details selector. This policy will allow traffic coming from service account bookinfo-product page to access details through get method. Now, in our app, the details are available and the graph already has turned this piece to green. Let's create a reviews viewer policy to get reviews reachable with similar rules. And now, the reviews in our app are back, but without ratings. Ratings are still throwing errors. And the Kiali graph is showing the current state accordingly. Reviews version 2 and Reviews version 3 has still red colors because no traffic is passing through them, because of ratings actually. Now it's time for ratings. The rules are quite similar here. Yes, in the browser, the Bookinfo application is all fully functional right now. And in Kiali, the graph is back to all green. Let's check istio5 section and filter all the authorization policies. Now, we have an allow nothing rule for the whole mesh and here the other viewers. This means any other traffic between our services, like post requests for example, or any new traffic source, will not be allowed. Depending on your authorization approach, you can have very well-defined and strict rules to protect your services. Let's have a look at the certification management in Istio. This is a diagram of key and certification flow in Istio. So when a service is started, it needs to identify itself to the mesh control plane and retrieve a certificate in order to serve traffic. As we talked about it in the previous slide, istio has a built-in certificate authority. The Istio agent creates a private key and a certificate signing request, and then sends the certificate signing request with its credentials to istio for signing. The CA in istio validates the credentials carried in the CSR. Upon successful validation, it signs the CSR to generate the certificate. The Istio agent sends the certificates received from istio and the private key to Envoy. Istio agent monitors the expiration of the workload certificate. The above process repeats periodically for certificate and key rotation. It is important to note that For production-grade clusters, you should use a production-ready CA, such as HashiCorp Vault, and put your certificates in an offline machine out of reach. Let's now demonstrate how to configure Istio with a root certificate of our own when we set up our Istio cluster. First, we need to create a folder for our certificates in our Istio root directory. I named my directory as CA certs and cd'd in there. Then, let us generate our root certificate with this command. So, here are the 4 files that are generated with this command. Root ca-conf is the configuration for OpenSSL to generate the root certificate. Root cert CSR is the generated CSR for the root certificate. Root cert PEM is the generated root certificate. Root key PEM is the generated root key. Now, we will create our immediate certificates. Root certificates should not be used directly because it is very dangerous and also not very practical to use them. Here, they are also created. Before moving on, I need to remind you that you need to delete if you pre-installed Istio, or at least delete the Istio system namespace to configure Istio to use our certificate. You can as well start with a fresh cluster. Let's also clean up the default namespace. Now, let's create Istio system namespace again and create a secret including all these certificates. And here we'll install Istio back again, so that Istio Certificate Authority will read these certificates and key from the secret mount files. We can also get our Kiali, Grafana, Prometheus add-ons back. And now, we can also get our bookinfo and some traffic default rules from the samples folder. But I guess we won't need them. Now, let's deploy a policy for our workloads to only accept mutual TLS traffic. Strict mode here identifies that. And we also need our bookinfo application to be up and running. So now, we will check if the workloads are signed with the exact same certificates that we just plugged in. Please make sure you wait at least 15 seconds to see this takes effect. I guess I tried a little early. Let me check out the pods. Okay, here they are. Let's retrieve the certificate chain of details app using OpenSSL when we're trying to connect to product page. As the CA certificate used in this example is self-signed, the verify error num19 self-signed certificate in certificate chain error returned by the OpenSSL command is expected. Now, here in the txt file, we have the certificates and we'll clear the rest of the certificate details with the sed command. Let's check the search spam. Yes, here are certificates extracted from the traffic between two services. And now with split, we can split these into 4 different files. Now, we'll verify if the root certificate is the same as the one we specified. First command will dump certificate information of our root certificate. The second command will dump certificate information of the one we just extracted from the traffic itself. Let's check if these match. Yes, they're identical. So, we just ensured Istio used our root certificate in mesh traffic. The second step is to verify the CA certificate is the same as the one we specified. Yes, you can see it is identical with the one we use. Let's also verify the certificate chain from the root certificate to the workload certificate. Yes, this one is also verified. So, in this example, we made sure Istio signs the workload certificates with the ones we plugged in to the Istio certificate authority. In this section, we will learn how to collect, view, and customize telemetry information from our mesh. Istio has an advantage in terms of observability because all of the traffic is handled by Envoy proxies in the data plane. Your service mesh will generate very detailed telemetry information for all service communications with Istio. Without having to develop a solution, you can have observability of services to troubleshoot and optimize the applications. So, in this section, first, we will learn how to visualize our metrics with Prometheus and Grafana. Then, we will learn how to have our application participate in tracing with Jaeger. And afterwards, we will have a look at Kiali in a bit more detail. So, let us begin. Let us look at how to visualize metrics with Prometheus and Grafana. The standard Istio metrics are exported to Prometheus by default. Prometheus is a modern monitoring tool to gather metrics for distributed architectures, and it is used by many applications and the underlying tools to collect and store metrics. By integrating your service mesh data, you will have a nice unified approach to monitoring metrics. Then, as an Istio add-on, your metrics can be monitored in Grafana, which is an open-source visualization and analytics tool. Let us head over to a demo and see this in action. For this demo, we'll see the Prometheus dashboard and explore some metrics there. The book info is deployed on our cluster with defaults. It's up and running. Now let's open up the Kiali dashboard. We can see the requests from the browser, but let's create some more traffic on the whole application. To open Prometheus dashboard, we'll use the command just like for Kiali, istio dashboard Prometheus. And here you can execute Prometheus queries. Prometheus is not intended for graphical representation of metrics data. Grafana can be used for that. And here we have the Alerts, Graph, and Status tab. Let's query some metrics. When we type Istio, well, there comes lots and lots of metrics to be queried from. Some of them are from Istio control plane itself, and some are from the applications. Let's try Istio agent Go info. This metric gives information about the Go environment. And here's the graph related to our metric. Now, let's check Istio requests total. This metric holds the total number of requests that are coming. Here on the right, you can see how many times this metric has been seen in this time interval. Oops, sorry. Let's move on to the graph. Here we can play with the time interval and get a bit more detail about it on the timeline. Metrics have lots of dimensions to give a little bit more depth and understanding for that metric. Let's use one of these dimensions to get more information from these metrics. Let's see the metrics only that the destination service is the product page. You can see the metrics of the requests that are coming from our gateway. Now let's filter review service requests and add another dimension to our query. As you can see, we filtered all V3 requests using Istio's out-of-the-box metrics. Now, we'll learn to check if our Prometheus and Grafana add-ons are up and running. Then, we'll take a look at Grafana dashboards that come with sample installation. Now, let's make sure our app works, and we have some traffic on it. So, let's verify if Prometheus service is running in our cluster. We can also check Grafana service this way. Now, let's open Grafana dashboard. So, here is our Grafana dashboard. On the bar on the left, you can see Search, Create. You can create new dashboards here, organize, or export existing ones. Dashboards. Here you can manage all your dashboards. Explore, Alerting. You can create some alert rules and define integration notification channels. And Configuration menu. And you can manage Grafana instance overall. When you go to the search menu, you'll find Istio's default dashboard that was deployed with Grafana instance. Here we have the Istio control plane dashboard. In this dashboard, you see information like CPU memory disk and Go routine graphs, any control plane errors, any configuration sync problems. You can get more details by drilling down a graph in view mode. Here are some memory metrics in much more detail. Now let's have a look at the mesh dashboard. It has this nice overview of our mesh, with workloads, with services, and their success rates. You could see the errors and all Istio configurations in the same dashboard. Let's check a services details now. Here we can see the metrics coming from the data plane of Istio. These metrics can be changed and tuned for your application's needs. Let's go back and check Istio performance dashboard. Here we can find performance metrics grouped together. We have already checked service dashboard. We can also reach it from the menu. Let's have a look at the details service. Here on the top, we can filter all services in the mesh. In WASM Performance Dashboard, you'll find anything related to WebAssembly. And in the workload dashboard, we can filter the workloads by inbound and outbound services, by services coming to the one we are watching, and by services going out of it. And there are lots of interesting metrics which can be drilled down. A way to monitor and understand behavior of services is to monitor individual requests as they flow through a mesh, which is called distributed tracing. Service dependencies and the sources of latency within the service mesh can be observed by tracing. Istio enables distributed tracing through Envoy proxies and supports Zipkin, Jaeger, Lightstep, and Datadog. In the upcoming demo, we will see tracing in Istio in action with Jaeger. In this demo, first we'll take a look at the normal behavior of our app, and then we'll introduce some delays. We now have our Bookinfo application running in our cluster. It is running as expected. We already have some heavy traffic on it, and it is working fine. Now let's see how Jaeger tracing works in this scenario. To open Jaeger dashboard, we need to use our usual command for sample add-ons, istio5 dashboard Jaeger. Now here in Jaeger dashboard, on the left, you can see some search criteria. We can filter services by name, by operation name, by some tags and traces, by duration of traces, and the number of results. When we hit Find Traces, you can see we have some traces in our graph. Let's change the number to 50 and get a wider group. Now the load we create on the app is really high, so here for 50 traces, Jaeger samples only 3 or 4 seconds in the timeline. We can sort them by the longest, shortest, most or least spans. Let's go into one of these to see it in detail. Each line here represents a span. A span is a logical unit of work, and in this example we have 8 spans. Every span takes some amount of time, and we can drill down into each one of them. These tags can be used for filtering traces. Now let's focus on review service. We can filter only the traces that have the service we search in. As you can see, these traces show all the traces with reviews in it. Okay, now I'd like to introduce some delays for details service. Let's apply it. As you would remember from the traffic management chapter, when we introduced a delay in details service, the product service waited for 3 seconds, then showed this error. Yes, it is working as expected. Let's go to KLE to check it. It has not affected the overview yet, but let's go to the graph view. There it is. Details are causing us some problems. Now, we have an actual error in our KLE dashboard. If we want to trace this problem, we can go to Jaeger and look for it. Let's change the service to product page. Let's limit the results to 20. There, as you can see, we can detect the problem in Jaeger as well. It's not in all the traces, because we introduced only 70% of delays. Let's drill down this trace. Here you can see product page had an error while expecting details to return a result, and this took 3 seconds of product page's time. Let's go back. Here's another one. Oh, this one has a warning. Its parent span probably has not been reported yet. All the tags are here for this service. Let's try another one. All errors return at 3 seconds because of product services hard-coded configuration. And this one had no errors and all services are looking good. It took only 52 milliseconds. So, Jaeger is a very useful and easy to implement tool on Istio. Make sure you check how to configure it properly for your application environment before installation. In this demo, we'll go through interesting features Kiali offers by using the last configuration we made on the Bookinfo app. Kiali is a tool that offers way more than observability. It helps you configure, update, and validate your Istio service mesh. Now, before diving into Kiali, let's lower down our delay percentage to 10. So we will still see some errors in our mesh, but we'll also get most of the traffic going. In the graph, we can detect there is some error, and we also have traffic going in our cluster. So let's start examining Kiali. Let's start with the overview section. Overview gives us a summary of our mesh, the workloads, and the services. And all these can be broken down by health, or MTLS status, or namespace labels. We only have 2 namespaces for now, default and Istio system. Let's use namespace filtering. We can also get the health information for app, workloads, and services. Let us go to Graph menu now. In the graph, we will have a very informative and clear visualization of the traffic between our services. The graph has different versions: app graph, service graph, versions app graph, and workload graph. These versions provide different focus views on our app by grouping accordingly. The left bottom part helps us modify the graph view. On the display section, we can add more information and formatting from our data plane to the graph. For example, when we add request rate, we can see the rates here in the graph. When we pick request distribution, we can see the total traffic distribution between services in percentage. And with response time, each service's response time is displayed on the arrows that represent traffic. With cluster boxes, Kiali provides us with a diagram that shows different clusters in different boxes. Namespace boxes are also working quite similarly. We can try all of those here, but a very popular feature of this graph is the traffic animation. It gives us an animated representation of our traffic in the mesh. With Show Badges, you can add tiny badges on services in the graph, if there's a circuit breaker or missing sidecars, etc. Now, let's remove our fault injection rule. We will slowly see the red arrow disappearing and the Details app going full green in the graph. Let's stop the traffic animation for a while and create some problems by deleting our review service. In less than 30 seconds, current graph caught there's a problem in our mesh. And now it is quite apparent that we're having issues. Yeah, now we lost reviews altogether. Now we're back to normal and we've applied sample YAMLs again for our app. I'd like to show you this tiny watch icon, which will take us to replay mode. In this mode, we'll watch our graph change in the interval that we pick, with different speed modes. This is a very powerful feature because most of the time it is not very easy to put your finger on a problem while things keep changing in a cluster. Here we can clearly see details going back to normal. When we are in Graph View, when we double-click on a service, let's try reviews for example, it takes us to the Services menu and it provides a nice overview of a specific service. On the top left, there are also traffic, inbound metrics, and traces tabs. In the Traffic tab, we can see inbound and outbound traffic of that service, with rate, success, protocol, and a link to view the metrics. From here, we could go to one outbound workload, and it takes us to the workloads page. And here we have even more details about our workload. Traffic details, logs of that pod, Istio proxy and our application container logs can be separated with these checkboxes. And inbound metrics such as request volume, request duration, throughput, size, and TCP metrics that we don't have any data here. And outbound metrics for reviews v1. And we have the traces here. Here in the cluster on the left, we can see some greens, but there's also a group of reds, and underneath this graph, you can see the comparisons with some other metrics from this service. And you can also view the spans details. We have an overview of the Envoy metrics here as well. Now, let's check the Istio config section. So far during the training, we've used this menu to investigate and edit Istio configurations. Kiali helps you to get a more detailed validation on service mesh definitions than applying the YAML files through kubectl. It has advanced filtering and navigation for Istio configuration objects such as virtual services and gateways. Let's go back, and here in the actions, Kiali offers a bunch of Istio configurations to pick from and create them using wizards, so you won't have to deal with YAML files or possible errors. Kiali interface validates the most common Istio objects. To check out all the interesting features of Kiali, you can visit kiali.io. I would now like to bring your attention to the Service Mesh interface. So far, we've talked about microservices, the problems they solve, and how the networking layer had to evolve into a much smarter version of itself. While Service Mesh technologies are getting more and more popular, Service Mesh vendors keep providing new features. This is both exciting and scary at the same time, because while application developers enjoy using these features, they may be locked into a vendor-specific implementation. So, in 2019, Microsoft has announced their ongoing work on Service Mesh interface. The main goal was to create an abstraction layer on various types of Service Meshes implementations, which will create a standard interface, a basic feature set, and community to drive innovation efforts on Service Mesh technologies. So, developers will not spend a lot of time trying to understand different features that a Service Mesh offers, using this set of functionality, and they will be able to jump in and start using any product. 10 service mesh providers above so far have implemented the common standards, Istio being one of them. You can find a total list of providers and SMI spec in smi-spec.io. So, the service mesh interface will be covering traffic policy, traffic telemetry, and traffic management topics, while also providing portability and flexibility. SMI APIs are expected to mature over time, and the current capabilities will definitely extend.